Hey everybody. So today is just a fun video I want to show you. I'm in Jupyter Notebook and I'm using the Pandas package. And I'm working with a data frame in Pandas and I'm looping through it and I'm trying to figure out, because we've got 400 columns, 400 plus columns. I want to figure out what columns the total value, like percentage of each of those columns, the percentage of how many filled in values they have. It took me quite a while to actually get something working in there. I was getting value counts, which gives me a sum of like each. So if we had a data frame and it has a value, let's say it has a string value of hello, another string value of dog, and then cat, and then hello at the end. So it's got four values. Well, it returns it kind of groups them and will return and say, okay, you've got two hellos, one cat, one dog. And I was messing around trying to find different ways to do that, to just get a total value so that I could do some math real quick to figure out the percentage. And all I had to do was add sum to the end of that, and then that would output the sum value of all those values that are filled in. And then from there, I can figure out the percentage of actual values filled in each column. And then from there, I can figure out, okay, if this is below a certain percentage, or maybe it's like less than it's almost nothing, like it's 0.001%. It's very, very small. There's like 5 out of 10,000 values filled in. I can figure that out really quickly, and that's what this bit does. Is it creates at the end a data frame that has those percentages. So if I run this, and I already have, but I'll run it again, you can see below we've got the name of the column, and that's what this is above. We've got the total value, and really this is the total value counts, the total sum, and you could see we've got, and that's how many column or rows we have in the data frame. So right off the bat, by seeing that number, I know it's 100% filled in. And then this value down here shows you that it is. But down here, you can see we've only got 1,300 values. And then we've got 10%. And so from here, what I can do is I can figure out the columns below a certain amount. So I can loop through the DataFrame.columns and then the value counts percent that I just created, or that data frame, which I'm not looping through this data frame. What I'm looping through is the list that I created up here that I was appending those values to. And so if we just look at that real quick, just as a visual for you guys, you can see that's just a list of numbers. And those numbers are the percents for each column. So I can loop through, and that's what this zip function is that I'm using here is for. So I can loop through both of those at the same time. So I'm doing a regular for loop, except for I'm doing two iterators. So I've got I and N. I just put I for iterator. I try to make these something that makes sense, so that when I go back to it, or a good example is like for word in words, making it really clear what it is. But in this case, I just put I and then N. N is the actual number value, so that kind of makes sense. And then I'll say, okay, if N is less than 1%, then then what we'll do is just append that value to columns below 1%. And then I append I because I'm appending the column name. So actually what a good value for that would be is C. So we can change that to C. And now we have a list of column names. And then down here I'm just getting a length of all of them that are below 1%. In this case, that's well below it. And it's probably because I changed that I value. If and let's run this again. Oh, I know exactly what the problem was. So I'm going to rerun this data frame real quick, but I'm going to pause it because that data I can't share. So I'm going to pause the video real quick again. And I reran that code there, and the reason why it didn't work is because I already cleaned out all those below 1%. So now, if we run this again, we'll get our list, and then we'll run that, and then you can see the length of our columns below 1%, which is 224. Now I can create a data frame of columns below 1%, and this is just for me so that I can export it out to CSV and then look at it or share it with other people. So I create a data frame here, and then I'll after create like a because I created a function above that would allow me just to put in that data frame, and then it'll create a CSV really quickly. But for this one, I'm not going to show you that, but that's why this is here. And then here, what we can do, since we have a list of all the columns that we know are 1% below, and just to show you that visually, I'm going to put it here. I'm going to pause the video real quick and run this, but I don't want to show all the data, so I'm going to pause the video. So here are some of the values in that columns below 1%, and so I'm going to close this preview real quick. Now that we have that list of columns, what we can do is just loop through that list. So for C column, in columns below 1%, I'm going to loop through that and just pass that iterator into this right here, because this is just dropping the column from the data frame. And so usually you would put a string here, which is what we're passing through, because that list of columns is just a list of string, and each of those strings are a column name. And so we're looping through that list, and then this line of code is just it's for every iteration it runs through and drops a new column. There may be a better way to do this. I'm sure there's a better way to do everything I showed you, but this gets the job done. And I don't know if I showed you the total shape of the data, so I'm going to show you that real quick so that you can see what it does at the end there when we actually drop it. So if I do data frame, and all these abbreviations, so DF means data frame, RM means room, and then OFF is just a filter that I added earlier for specific types of things. So all we have to do is put shape, and then this will tell us our rows and then our columns. And then down here, I'm just looping through all the columns and adding one I think there is a count. There could be a count or like a sum for columns. But real quick, I didn't want to Google it. I knew I could do this really quickly. So in this instance, I'm just looping through and essentially doing nothing with this iterator. But this function or this variable here is just, it's taking the value of whatever it is plus 1. So it'll loop through, adding 1 each time. And that's what this addition and equals means. So at the end of this, what we're going to know is the length of the columns inside of that data frame after they've been dropped. So if I run this, and this one takes a minute because it's looping through and dropping them, and then and actually, now that I say this, I created this absolutely for no reason. I guess I wasn't thinking, because right here I already answered that question. So if we run this shape, we'll see exactly how many columns are there, and you can see it down there as well. And that weird way I was doing that, I don't know why I thought of that, but shape gives you exactly that. So it'll tell you, again, it'll tell you the row and column. So anyways, you can see now, cleaned up, we're down from 400 to 200. And I guess it depends, like, if you're going to do this workflow, it depends on the data that you're going to be messing around with. If there's, like, if you know the data really well, then you could probably, you probably know the columns well enough to know that there's a good potential that these, a good amount of them could be combined, and then we can get a higher percentage. I heard that, above 1 or 2% is a safe range, and that's all dependent on what you're doing, using the data for. If you're using it for machine learning, 1 to 2% filled in values for those columns, but that kind of depends on what you're trying to do. If you do have below percent, you can drop it just like we did here, but again, you can do things like combining columns, merging them together, doing a lot of different, or maybe there's not a lot of data, but it's really insightful to know which ones do have those inputs. So you can just do a Boolean there. You can just say true, false. True for it does have that, and false that it doesn't. So anyways, I wanted to show you that because I thought it was kind of fun and a cool way to reduce your data frames down a little bit. But I just want to mention again that doing this is nice, but it's probably worth the extra few minutes of just evaluating some of those columns to get an idea of if that's the route you want to go with, being that you want to drop all those columns and ignore them entirely for whatever you're trying to do. If it's machine learning, those columns could potentially be helpful. They could not, but I would say try to determine that before you drop them. Anyways, that's what I got. So let me know if you have any questions. And this code doesn't really share anything, so I will try to post it below in the description. And at some point in the future, I'll do a full-on working with data frames and SQL stuff. And I've got to set up a testing environment for that, so that'll be in the future. But I'll try to remember to put this below, or maybe in the OneDrive. But anyways, thanks a lot for watching, guys. I will see you in the next video.